I don't get it. Why don't you just come sit over here and then we can edit and do stuff to camera together? It'll be a lot easier. I just don't want to sit next to you. He's trying to make a point, that's all it is. So in this video, I'm not really trying to make a point, it's more about explaining how affinity works both in pod and node. This kind of explains anti-affinity, and that's what we're talking about in this video. I guess what he said. To start, we're going to take a look at node affinity. I'm carrying on from the previous video here, which you'll see linked somewhere in this video now. And we're going to be adding a couple of labels to nodes. In fact, I've already added those labels to the nodes, which I will go through with you in just a second. And then we're going to take a look at pod affinity. So with node affinity, we are basically saying which nodes we want to target based on affinity rules. Now, I'll explain that a little bit more as we go through in a second. Let's take a look at the labels first. So I'm just going to do a kubectl get nodes, show labels. Okay, so we'll do show labels. And what I've actually done is I've added a new label here called topology.kubernetes.io/zone. That is arbitrary. It's not a required one for topology, but it's kind of a, I don't want to say a standard, but let's just say it's a best practice. That's probably a better way of wording it. So I've got zone 1 for worker 0, zone 2 for worker 1, and zone 3 for worker 2. Now, I don't have more nodes. Otherwise, I'd put a couple more into zone 1, a couple more into zone 2, and a couple more into zone 3. For this demo, let's imagine that setup. Okay, let's pretend we have multiple nodes, because that will hopefully help you understand how this might work a bit, but we'll cover it as best as we can. And we've also added this other one called optimized, and then optimized is equal to GPU on worker 0, CPU on worker 1, and memory on worker 2. The reason I've done that is because I want to, again, pretend that I have certain nodes optimized for certain workloads in different zones. Let's get started. We want to deploy a web workload, which needs to be targeting CPU, and we want to deploy a database workload, which needs to be targeting memory. We'll then take a look at the topology stuff afterwards. So let's jump over and take a look first at what we've got. So I've got these two definitions here. Web 1 is the same as we've been doing all the way through. It's an Nginx workload. It's got nothing fancy going on it, and you know what, replicas needs to be 3. It's copied and pasted from the previous episode and has the tolerations removed. So that's all that is. The database one is copied from the nvars one, if I remember rightly. Just double check. Yep. So it's copied from here, and I've changed nothing. Everything's exactly the same. We've got the MariaDB password, the config map, the stateful set, and the service. I'm not changing any of that because that just needs to stay as it is. All we need to do is do the affinity with it. Let's start on that first. So we're going to do node affinity. Affinity comes under a pod spec, and the way we do it is we type affinity. Simple. And what kind of affinity do we want? Pod or node? Well, we want node affinity. So there it is. The next bit is where it starts to get a little bit wordy in terms of the way we do this. So there's two options available here. There is required during scheduling, ignored during execution, and there is also preferred during scheduling, ignored during execution. So the first one, required during scheduling, ignored during execution, is where the scheduler will not schedule the pod unless it meets the rule that we specify. This kind of functions like the node selector, but there's a little bit more to the way it works. You'll see in a second. And preferred during scheduling, ignored during execution, is where the scheduler tries its best to find a node that meets the criteria that you set in the rule. But if it can't, it just goes, hey, well, I couldn't find it, so here's another node, you know, deal with it. At least your workload's deployed, don't moan at me. So they're the two kind. The ignored during execution bit that I mentioned as part of those two definitions means that if the node label changes after the workload is deployed, so after a pod's deployed to it, then the pod just keeps running anyway. It won't change during execution. It won't go, oh, well, you know, the node's not got this label anymore. I'm going to shuffle on over to this other node that has got the label. That won't happen. You would have to redeploy your workloads. So let's take a look at how we can do this. Again, we've got affinities, we've got node affinities, and then we've got those two options. We've got required during scheduling, ignored during execution. So let's take a look at the required one first. So we'll do required during scheduling, ignored during execution. And that's a long one to write out, but I know I just pressed enter there and it filled it in for me, but it is literally as I said it there. It's required during scheduling, ignored during execution. I really feel like there is a better way of writing this. I just don't know what it is. So the next section is the node selector terms. That comes under there. And then we've got an array of what we want to do. So in this case, we want to match the expressions or fields. So we'll do match expressions. That's what we're doing here. And we've got a key and an operator. Now this is starting to look like the labels bit we were talking about before with the node selectors. So what we're looking for here is a key of what? Well, we've got optimized, or we've got that topology.kubernetes.io. /zone. We're talking optimized at the moment. So for example, if we wanted the topology one, we could do topology.kubernetes.io/zone equals zone 2. And that basically means that if there's no nodes deployed in zone 2, do not deploy this workload because this is required. We're talking about optimized in this case, so I'm going to do optimized. The operator is just, well, I mean, it's kind of that. It's in this, it's a weird way of wording it. Let me write it out first and I'll explain it a bit more. So there's in and not in, okay? And in this case again, and then we've got values. So my values that I'm looking for in this case is, because I'm doing the web one, CPU. So we're saying if CPU is in the label optimized, that's kind of the way I read it anyway. It might not be the way it's interpreted on the website. I'm not actually sure, to be honest. I should probably have read that before I did this. But basically that's what it's saying. It's saying if this label has this value, that's probably a better way. So we've got our expression, that's there now. Now let's also imagine that in this case, we also want it to ideally sit in zone 2. Now we can do more keys and operators here. We can do required to sit in zone 2 if we wanted to, but I don't need it to be in zone 2. It could be in zone 1, it could be in zone 3 if there's CPU optimized nodes over there. But ideally, I'd like it in zone 2. In that case, I can do the preferred. And that's what we're going to do here. So I'm going to do preferred. Preferred during scheduling, ignored during execution. Now with this one, you need a wait and a preference. So when I hit enter, you'll see those two appear. There we go. And the preference is the same as the node selector terms. Basically what we're saying is we want to match expressions, and I want it to be topology.kubernetes.io/zone. And again, operate it in, and values will be zone 2. In fact, I'm going to do zone 1. I'm going to do zone 1, and I'll explain that now. So what I'm saying here is I need, no matter what, I need to have a CPU optimized node. That's this label here. That only exists in zone 2. Now, by setting zone 1, I'm saying if you can find a node that's in zone 1 that has CPU optimization, stick it over there instead. If not, deploy it anywhere else you can find one. So in this case, I don't have a CPU optimized node in zone 1. So this will be a case of it will try its best. But if it can't find one in zone 1, it's going to go somewhere else, and we know we've got one in zone 2. So I just want to show you how that would work. Now with the weight, the affinity weight is between 1 and 100. And when the scheduler finds a node that meets all of the scheduling requirements of the pod, the scheduler iterates through every preferred rule and adds the value of the weight for that expression to a sum. The final sum is then added to the kind of total score of other functions for the nodes, and the node with the highest score is the one the scheduler deploys to. So just to kind of explain what I mean by that, if I set this to 100, for example, what I'm saying is that if you find a node that's zone 1 and CPU optimized, then you deploy it to that node. Do it now, right? Because it's got the highest possible score. Now, if it was doing this and it was like, yeah, but there ain't one in zone 1, but there is one in zone 2, well, it ain't going to get that weight. That's not going to happen. All it's going to get is this. And that doesn't have a weight because it only happens on preferred. So it's going to be a low score, but it's still going to get applied to zone 2 because nothing else meets that requirement. So what I could do is I could add another preference here and say, if that doesn't work, go for zone 2, which is, a score of 50. Now, what would happen here is it would say, right, let's have a look in zone 1. Oh, look, I found a node in zone 1 with an optimized CPU. That's got a score of 100. That's the highest one so far. And then it carry on and go, oh, I found another node in zone 2 that also has CPU optimized label, but that's only got a score of 50. And because of those weights, zone 1 will win out. Okay, so that's essentially what's happening here. Now, when I deploy that, it's going to go to zone 2 either way. And if I delete that, it's still going to go to zone 2 because this right here, this is a requirement. This is just a preference. I'm going to leave that in though, just for the sake of explaining things a little bit better, and we will go ahead and deploy that in a few minutes. Now, so that I don't have to write all of this out again, I'm going to go ahead and grab this, copy it, jump over to the pod spec for the database. I will paste that in, and we'll just take a look at what we've got. Well, optimized, I want to be memory. Again, absolute requirement. And this time we'll say, ideally we want it in zone 2. That'd be the best place for us, but zone 3 is also acceptable. Again, if I don't define zone 3 here, because that's the one with the memory optimization node in it right now, then it would still deploy to zone 3. That's fine. In fact, I'll do that as an example. Let's delete that altogether. So I'm saying that I want zone 2. I really want it to be zone 2 with a memory optimized node. But if it can't go into zone 2, just stick it where you can. So this will still get deployed to zone 3. And I just want to show you what I mean by that. So here I'm saying I really, 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 really want zone 1. But if not, we'll go for zone 2. If not, wherever else you can find. Here I'm going, I really, really, really want zone 2. But if not, anywhere else you can find. That's pretty much what's happening here. I hope that makes sense. And if it doesn't, I'm sorry, give me a comment down below and ask me and I'll try and explain it again in another way. So we're going to do kubectl apply f, and we'll do 20 affinity, and we will do web first. And just before we do, let's clear that. We'll do kubectl get pod name learning, and we will watch, and we will actually output that as wide because I want to see what nodes these are on. Okay, so we'll see all the nodes that come up. And yeah, okay, so let's go ahead and deploy that first. So we'll see what happened there. Well, remember from before we had KX Worker 1, which was optimized for CPU, and it was in zone 2. So it ended up on zone 2. That's where it ended up because it required that CPU optimization. So that's cool. Now for the MySQL one, we're going to go ahead and just deploy that. So we'll do database there. And again, we'll see what will happen is it really wants to go to zone 2, but unfortunately there was nothing in zone 2 with memory optimization. So it just found anywhere else it could. And in this case, that was worker 2 because worker 2 had the memory optimization label. That's node affinity. I hope that makes sense. I hope I've covered that over and over again enough in the way I've worded it that it makes sense to you. I really do. So that's what we've got there. Now, let's take a look at pod affinity instead. We'll go ahead and delete everything in here. There we go. And if I haven't said before, if you don't put a file in, it just deletes everything in the folder. Little tip there. So that's everything going and gone. Okay, cool. That's it. There we go. That's node affinity. Now let's jump over and take a look at pod affinity. So pod affinity and anti-affinity, I should say. In fact, I should say interpod affinity and anti-affinity. That's the technical name. But basically what it is it allows you to constrain which nodes your pods can be scheduled on based on the labels of the pods already running on that node, instead of node labels. What does that mean? Well, it basically means that if I just go ahead and delete all of this, because this is not going to be used in the next section, I'll do the same on here too. What it means is I can say, well, I can target the labels of the pods. So in this case, we've got the template for the pods. These labels will automatically get added to the pods, and I can use them as my guide, as it were. What does that mean? Well, that means if I want 3 Nginx pods deployed and I want 3 database pods deployed, then I could say, okay, scheduler, listen up. This is what I want. I want 3 Nginx pods deployed, but I don't want them to sit on the same nodes. I also want 3 database pods deployed, but I want 1 database pod to sit next to an Nginx pod. And I don't want any database pods sat on the same node. So what does that mean? Well, it means I've got 3 nodes. I've got 3 pods of database and 3 pods of web. It means I've got 1 Nginx and 1 web sat next to each other on one node, and then on another node, and then on another node. That's affinity and anti-affinity. I'll show you how it works though. Let's go through and use the example I just gave. Why not? That works. For the record, I just want to quickly say, if you're running databases in Kubernetes, be extremely careful because you need decent storage underlying it. If you lose that data on the storage, you're going to start having issues with your databases. And if you have the option, just use a managed service. Honestly, it's fine. Don't feel like you've got to fit everything into Kubernetes. That is like the #1 tip I can give you. I'm sitting here telling you how great Kubernetes is every week, you know, but I'm also going to say it's not for everything. If you're doing batch workloads and things like that, yeah, absolutely use Kubernetes. If you need something that scales, yeah, use Kubernetes. But there might be something else out there that's better for you. And in the case of databases, and if you're running Kubernetes in the cloud, just use one of the managed services. Honestly, it's going to be more reliable. It's probably going to be faster. It's going to be, well, easier to manage. You don't have to manage it yourself. It's the whole point of a managed service. So I don't want to poop on Kubernetes right now because, you know, it's what I'm trying to teach you here. But just stick a database in a managed service if you have that option. If you don't have that option, yeah, you get it in Kubernetes. It does, you know, you can do that. It's fine. I run all my databases personally in Kubernetes, but these are ones that sit at home, not in a production environment. In a production environment, I would consider maybe doing it somewhere else. I don't actually run databases in my production environment, to be honest, because I don't have that set up in my particular job. But yeah, there's not everything belongs in Kubernetes. That's what I'll say. Okay, just a little addendum there. And I'm sure people are going to jump potentially in the comments. They might not, you know, I don't have that many followers at the moment, but maybe in the future, some people will jump in the comments and tell me why I'm wrong. And that's fine. If you think I'm wrong, you tell me I'm wrong. But in my opinion, if you have that option for a managed service, because you're running in the cloud anyway, just do it. Use it. Make use of it for a database. Cool? Cool. Right. Now let's go back to why Kubernetes is so great. Okay. So try and not talk you out of carrying on these videos. Okay, so pod affinity and anti-affinity. Let's start writing it out. So again, lives in the pod spec. So we'll do affinity. We will do pod affinity this time. And then we'll pretty much do the same thing as we had before. There's another quick note I need to make about topology keys in a second, but I'll do that as we get to it. Okay, so again, we have required during scheduling, ignored during execution. And the first thing we're going to do is say preferred during scheduling here. And the reason I'm going to go for preferred is because if I go ahead and set this particular one. Let me write it out first and I'll explain. Okay. So topology key, that is, it's kind of saying, look in this particular zone in this case, look in this topology for this particular setup. Well, basically what it means is the scheduler can only schedule a pod onto a node if the node is in the same zone as one or more existing pods with a particular label, which we're going to write out. This essentially means the scheduler must place the pod on a node that has the same topology label. In this case, again, the topology key can be anything you want it to be. We're just using topology.kubernetes.io, but it has to be consistent, right? So every single node needs this same key, not the value, just the key. I just want to stress that. So in our case, topology.kubernetes.io/zone. That's our topology key. And we also need to spell Kubernetes right. Well, I do, you might not need to. We don't need that to be equal to anything. We're just saying, look for this key on nodes. That's it. We could have used the optimize key. That's the other thing we could have used. But in this case, we're using the zone one. Right, wait. Exactly the same as it was in Node Affinity. Same rules apply, get scored and all that sort of good stuff. So I'm just going to stick this as 100 because I want this to be a pretty high scoring rule. And what is my rule going to be? So again, here we can use label selectors with match expressions, but I'm actually going to go ahead and use a label selector with a label instead. So instead of doing match expressions, which we can do in the same way, we can look for a label and say, is this value in this label? And that sort of stuff. But I'm not going to bother with that because I don't need to. I can just do match labels instead. And match labels works in exactly the same way as a label selector, like this does right here. That's it. So I'm going to be looking for, in this case, MariaDB. And the reason I'm looking for MariaDB, I'll explain in just a second. We'll go ahead and just write the rest of them out first. So the next is the pod anti-affinity. And again, I'm going to have this as a requirement, not a preferred topology key. I'm just going to grab that, copy and paste it. And then we will go ahead and do the same again. We'll have a label selector. It will match labels. And this label will be app equals nginx. Right, what have I written out? What is going on here? So what I've said is when you deploy X pod, so we've got 3 pods being deployed. 3 will get rolled out. Look for a particular label on any node. As long as you find a node with that label, let's target that. This will then go, right, I'm looking for a pod that's already deployed on this node with the label app equal to MariaDB. And I really want to do this if I can. If I can't, just deploy, right? Because it's a preferred. During scheduling, ignored during execution. For my anti-affinity, I'm saying, right, now look for a pod on this node with app equals nginx label. And if you see that, don't deploy me here. That's what the anti-affinity is. It's saying, push it away, essentially. There's already one here. You're not welcome on this node. Go elsewhere, please. That's basically what it's saying. There ain't enough room in this node for the both of us. That's pretty much what's going on here. The only reason it works is because this label is on every single node. If I start removing this label from certain nodes, it's just going to find the nodes with that label on and try and deploy it on them. If I have 3 nodes without it and 1 node with it, then only 1 node's going to get used because this is the key we've defined. I hope that makes sense. I'll tell you what else you could do here. We could do something like topology key equals OS equals Linux because all of the nodes have OS equals Linux, if you remember rightly from last video. So that's kind of what it's doing. It's collating all the nodes together that have this label. Then it's going to start trying to deploy. That's probably a better way of describing it. I'm not sure. Hopefully it makes sense though. So yeah, we want to be on a node if we can that already has a MariaDB node on. If it hasn't, just deploy it. And then any other pods that come along for this particular workload in this case is going to look for an app nginx one. And if it is there, it's going to go look for another node. If it can't find another node, it just won't deploy because this is a requirement. Now, only do this if you know it can work. If you have replicas of 5 and you only have 3 nodes, you ain't getting 2 pods. That's the thing to remember. So you might want to prefer this ideally. In my case, I know I've got 3 nodes. I know I've got 3 replicas, so I'm safe. But just bear that in mind. If you've got 2 pods not deploying and you've got a required here, that's probably why. Just bear that in mind. Right. So the next one is the database. So we're just going to grab this. We're going to copy this and we're going to paste it. And I'm going to set this one to be required. Why am I setting this to required when the other one was not required? You might be wondering, or you might not. I don't know, Well, either way, I'm going to tell you the answer. The answer is because I already know that at least 1 pod will be deployed because this is a preferred. Okay, so I know there's going to be at least 1 app nginx pod somewhere because this is only preferred. This isn't a requirement. That's why I'm okay with this being required. I could prefer this again. It'd be fine. Also, I want to change this to nginx and this one's MariaDB. And the reason being, I don't want MariaDB pods being on the same nodes. I only want them to be on the same nodes as nginx. Whereas with the web one, if I set this to required as well, nothing will deploy because both of them will go in, well, I need a MariaDB one. And then the database will go, yeah, well, I need an nginx one. And then the web one will go, yeah, but I need a MariaDB one. So who's going to go first? By setting this one to be preferred, I know that nginx will go first. You have to think about your infrastructure here. You have to think about your architecture here and the way things are going to deploy, the order of operations, as it were. And that's yeah, that's essentially it. So I'm going to deploy this now. I'm going to deploy it all at once and we'll watch to see what happens. So let's jump over to this right here. We're already watching. So I'll do qctl apply f and we'll do 20 affinity. Okay, so let's go ahead and deploy that, jump straight back over and let's see what happens. A lot of stuff straight away. Do you know what? I should stop using the watch command. I should actually do this instead. You know, do that because it's easier to see. So we've got one Nginx pod deployed on worker 0, one deployed on worker 2, and one deployed on worker 1. We've also got one MariaDB pod deployed on worker 0, one deployed on worker 1, and one deployed on worker 2. So we've got that affinity and anti-affinity going here. What happens if I increase those to 5? Let's take a look. If I do the Nginx pod to 5, what do you think might happen? Will they deploy? Because this is a requirement, right? What about database? If I set this to 5, will this deploy? I mean, I already know the answer, but I'm just trying to make you think about whether these will. Let's go ahead and apply it and see what happens. Yeah, they're just going to sit there. They're not going to do anything. Okay, so the reason this ain't going to happen and the reason this ain't going to work is because these pods here are going, yeah, but my anti-affinity requires me, it absolutely 100% requires me to be on a different node, no matter what. The MariaDB one is doing exactly the same. So again, I've got more pods than I have nodes here. So I don't want to be horizontal, you know, pod auto scaling this out because if I do, this is going to happen. I don't want to be manually scaling this out because if I do, this is going to happen. I'm going to need new nodes. Now, if I had the cluster auto scaler installed here, then this would start working because the cluster auto scaler would kick in and go, oh, I've got some pods here that I can't deploy. Spin up some new nodes. These pods then come along and go, cool, 2 new nodes, bang, deployed. And that's basically it. That's affinity and anti-affinity. And that's everything. That's all we've got for this video. You did this in the first 2 bits. You took over. I invited you here to help me out, make a point and all that. But I'm doing the outro. I'm doing the wrap up. Please be quiet. Fingers on lips. Okay. So that's everything you need to know about affinity, anti-affinity in terms of pods and nodes. That's pretty much it. There's a little bit more. As always, have a look in the description. There's a link and that will give you what you need to know. In the next video, we're going to be looking at ingress resources. So that's going to be kind of cool, getting traffic coming in from the internet into our pods. Well, not from the internet into our pods, but allowing us to actually maybe host a website in Kubernetes. I'll explain more in the next video. See you over there. You're not welcome. What?